In this video, I'm going to go through review 1 for the volume unit. So for number 1, for the cup with the dimensions shown, do the following. Set up and solve an equation to find the value of x as shown in the diagram. So this is something called a truncated cone, which was a cone that I cut the tip off of. So it's like I sliced that bottom part off. And this picture right here is a cross section of it, where if I were to cut this cone vertically, this piece that I see right here is what I've drawn there in 2 dimensions. So to figure out that top piece, that represents the radius of the top part of my cone. So if I know the diameter at the top is 6.4, I can take half of that to get 3.2 centimeters. Similarly, the bottom diameter is 4.8 centimeters, so I can make that 2.4 centimeters for that bottom part of the cup. That's the radius there. Now the x that we're looking for is the height of the small cone that I've chopped off. I can see that just the height of the cup is 10 centimeters. So I could label the entire height of my cone here as x plus 10. So that's the height of the big cone. So when I say set up and solve an equation to find the value of x, I can set up a proportion with these side lengths because these 2 triangles are similar. They both have a right angle and they share that angle down there. So I'm going to do a big over small equals big over small proportion for these similar triangles. So the big height of the biggest cone is x plus 10, and the small height of the cone is x. Notice I'm not using 10 because that doesn't represent a triangle side length, but this bottom piece right here would be a side length of that bottom triangle. So x plus 10 over x equals my big radius over my small radius, 2.4. And to solve any good proportion, I can always cross multiply. So just be careful that when you multiply across this diagonal right here, you're doing 2.4 times x plus 10. And I'm doing 3.2 times x. So I need to remember to distribute that 2.4 to my x and to my 10. I'm going to subtract 2.4x on both sides. And when I do that, I get 0.8x equals 24. And to undo a multiplication of 0.8, I can divide by 0.8 on both sides of the equal sign to find that my value of x is 30. So what that represents is the height of my small cone, so I could label that as 30, which would mean the height of my big cone is just 30 plus 10, or 40. So now I have enough information to find the volume of the big cone that I started with, and the volume of the small cone that I chopped off the bottom. So the process here is we're going to take the volume of the big cone, subtract away the volume of the small cone, and I'd be left with just the volume of the cup. So remember, the volume formula for a cone is 1/3 pi r squared times the height. And in this case, the radius of the big cone, if I look, is 3.2. And the height of the cone, the big cone at least, is 40 centimeters. So when I substitute in 1/3 pi times my radius squared times 40. And when I round that in my calculator, I get about 428.93 centimeters cubed. For a test or a quiz, I will tell you specifically what place to round to, but for here I'll just be rounding to the hundredths. Now for the small cone that I chopped off, that radius is 2.4 in the picture, and the height of that would be 30 centimeters. So I'm going to substitute into the same formula, 1/3 pi radius squared times the height. And when I do that, I end up getting about 180.96 centimeters cubed. So to determine the volume of the cup, I'm just going to take my big cone and subtract away my small cone. So that's 428.93 minus 180.96 to be about 248 centimeters cubed. And I know to round to the nearest integer because it says nearest cubic centimeter. So that just means there shouldn't be any decimals. For number 2, a basketball, if you're picturing that, that's in the shape of a sphere. And to find the volume of that, that's 4/3 pi times my radius cubed. I'll use a darker color here. The basketball has a maximum circumference of 29.5 inches. Which of the following would be closest to the volume of the basketball? Well, to get the volume of a sphere, all I need to figure out is the radius. But the problem is they give me the circumference. So I need to figure out a way to find the radius given the circumference. Well, I know the formula for circumference is the circumference equals pi times the diameter. So I can make some substitutions here. I know my circumference is 29.5, and if I want to solve for my diameter in this equation, I can divide by pi on both sides of the equal sign. Now, there's going to be a lot of inaccuracies due to rounding here. Like, notice I'm going to round this to the hundredths place. And then, from the diameter to get the radius, I'm just going to take half of it. So I find that my radius here is actually 4.695. Now, because these answer choices are pretty far away from each other, I don't need to worry about rounding too much. So I'm just going to substitute into my formula. 4/3 pi times my radius cubed. And when I cube that, I get about 433.5 centimeters cubed. So the volume that's closest to that is 435. Oh, I'm sorry. It should be inches cubed because that's the unit they gave me. But notice that none of them are very close. So it doesn't really matter what place you round to here, as long as you don't round to the nearest integer. So I'd always give myself at least a couple of decimal places for the first time that I round. Number 3, a packing carton in the shape of a triangular prism is shown in the diagram below. And they want me to find the volume. Well, remember, the formula to find the volume of a prism is the area of the base times the height. So in this case, the base is a triangle, because for a prism there should be the same shape on the front and the back. Those are my two bases. So I'm going to find the area of my base first. To find the area of a triangle, I just take 1/2 multiplied times the base times the height. For this base of a triangle on the front, it looks like the length of the base is 6 and the length of the height is 4. So when I multiply those all together, the area of my base here is just 12 inches squared. Remember, big B doesn't stand for base, it's the area of one of my bases. And I'm going to multiply that by the distance between my two bases, or how far it goes back. I label that as my height of the whole pyramid. So I'm going to take the area of the base, multiply it by my height, so my total volume is 120 inches cubed. For number 4. The greenhouse pictured below can be modeled as a rectangular prism with a half cylinder on top. The rectangular prism is 20 feet wide, 12 feet high, and 45 feet long. The half cylinder has a diameter of 20 feet. Find the volume of the rectangular prism portion of the greenhouse. Well, it's a prism, right? So I know it's the area of the base times the height. So if I consider this front part to be my base, I would find that area by multiplying length and width. And the height is just how far it goes back, or the distance between my faces. So in this case, my height can be considered to be 45. So when I multiply all three of those, I find that my volume of the rectangular prism is 10,800 feet cubed. You could also think about length times width times height as another way to consider the volume for a rectangular prism. Now for the next part, it says find the volume of the half cylinder portion. Well, I know the formula for the volume of the cylinder is pi times my radius squared times the height. For this half a cylinder part, I can see that my radius must be 10, but the question is, what is the height? Well, if you try to picture this, the other half a cylinder would be back there. So the distance between those two faces would be 45. So that's the height of my prism. So height doesn't necessarily need to be up and down, it's the distance between my two bases. When I find that volume, it's about 14,000 137. But remember, this is a half a cylinder. So I still need to divide that by 2 to find that my volume is about 7,069 cubic feet. Now, if I want the total volume of the greenhouse, that's just the volume of the rectangular prism plus the half cylinder. So if I add those together, 10,800 plus 7,069 is going to be 17,869. And I got to have a unit there, so that's going to be feet cubed. Number 5. A shape consists of a hemisphere, a cylinder, and a cone, all of which have a diameter of 6 centimeters. The cylinder has a height of 14 centimeters, and the cone has a height of 8 centimeters. So really, they want me to just find the volume in each of these pieces, and then add them to find the total volume. So if I start with the cone, if this diameter right here is 6, that means the diameter at the top should also be 6, which means my radius is 3. So that's the piece I care about when I'm plugging into 1/3 pi r squared times the height for the volume of the cone. So in this case, my radius is 3, my height is 8, and if I round to the nearest cubic centimeter, I'm just plugging that straight into my calculator. I get 75 centimeters cubed. For the cylindrical portion, the formula for that is pi r squared times the height. Now notice the radius is still 3 here, but my height is just the distance between the two ends of my cylinder. So my height is just 14. Again, when I plug that into my cylinder formula, I get 396 centimeters cubed. For C, if I'm finding the volume of a hemisphere, I could use the formula for a full sphere and then just take half of it at the end. So in this case, all I need to know is the radius. The radius is 3. So the volume is equal to 4/3 times pi times 3 cubed, or about 113 cubic centimeters. But again, this is half a cylinder, so I need to take half of that. And I'll get about 56.5. But if I round to the nearest cubic centimeter, that just means the nearest integer. It should be 57 centimeters cubed. So I found the volume of the cone at the top, the cylinder in the middle, and then the hemisphere at the bottom. So if I'm looking for a total volume, I'm just going to add those 3 parts. 75 plus 396 plus 57 equals 528 centimeters cubed. For number 6, given the pyramid below, find its volume. Well, there's a couple things here. To find the volume of a pyramid, I need to first identify the area of the base and multiply that by the height. So in this case, this is a rectangular pyramid because the bottom of it is a rectangle. So to find the area of that base, I would just multiply length times width, or, base times height. So the area of the base is just represented by 19 times 18, and the height of the whole pyramid is just 19. That's the distance between the base and the point on the top. When I plug all those into my calculator, I find that my volume is 2,166 meters cubed. So that's just knowing what formula to use and how to find the area of the base. So that bottom could be a triangle, it could be a rectangle, it could be a square, but the goal is always the same. Find the area of the bottom, multiply it by how far it goes up, and take 1/3 of it for a pyramid. Number 7. Ian needs to replace 2 concrete sections in the sidewalk as modeled below. Each section is 36 inches by 36 inches by 4 inches deep. What is the total volume of both concrete sections? Well, I could find them individually or add them, or I could try to do it all at once. The first thing we need to identify is what kind of shape is this. And it looks like a rectangular prism, the whole thing, where it's got a length, it's got a width, and it's got a height that it goes down as well. So try to picture that there. Well, it should go that far back. Right? So if each piece is 36 long, That means I could label my entire length as 72 inches, and this width right here is still 36, and the depth, or how far it goes up and down, is 4 inches. So if I'm finding the volume of this prism, it's the area of the base times the height, or you could think about it for a rectangular prism. Sometimes you'll see that it's length times width times height. It's just multiplying your 3 dimensions all together. So I can do 72 times 36 as a width times 4 inches deep as a height. So my total volume will be 10,368 inches cubed. Now for the second part. If Ian can mix his own concrete for $0.02 per cubic inch, so for each cubic inch of volume, it'll cost me 2 cents to make it. So this is a multiplication problem. If I want to know how much money it'll cost to replace both of them, I take my total volume in cubic inches and I multiply by the price per cubic inch. So I'll find that if I want to replace these, it'll cost me $207.36. Now I didn't need to round here, but in cases where you would need to round, remember that for money I want 2 decimal places, dollars and cents. Number 8. A hemisphere is cut out of a block of wood in the shape to the right. A rectangular prism is shown. What is the volume that remains once the hemisphere is cut away? Well, I start with a rectangular prism, and from it I remove a hemisphere. So the goal here is going to be to find the volume of the prism, find the volume of the hemisphere, and subtract them. So for the volume of the rectangular prism, that's a little bit easier. Length times width times height. So 14 times 14 times 7, and this is the volume of the prism, so I'll label it as such, is 1,372 centimeters cubed. Now for the volume of the hemisphere, it's going to be whatever the volume of the cube is, or excuse me, the volume of the whole sphere would be, divided by 2, or multiplied by 1/2. You could do all these in any order, but I'm going to do it all at once in my calculator just so I don't have to type it in more than once. The question is, what is the radius of this hemisphere? Well, the radius is the distance from the middle to the bottom, or the middle to the edge that way, or the middle to the edge that way, and I know one of those dimensions. The distance from the middle to the edge there is 7 centimeters, because that's the height of this prism here. So the radius at any given point should still be 7 centimeters. So the only substitution I'm going to make there is I'm going to take half of the sphere, but I'm going to plug in 7 for my radius. So the hemisphere just ends up being about 718.4 centimeters cubed. Again, my last step is just to subtract those volume, big volume minus small volume. So when I subtract 1,372 minus 718.4, I get about 653.6, or if I round to the nearest cubic centimeter like it tells me, 654 centimeters cubed would remain after I remove the sphere, from the prism.